Today in geometry, our focus is going to be on similar polygons. Now, talking about something that's similar means that there are certain things that are congruent and certain things that are related by some kind of a ratio. That's why we reviewed ratios and proportions for the last section. So let's take a look at our first couple things. Help us get the vocabulary started and our basic ideas going. So first of all, in this basic, definition here, similar polygons are polygons that have corresponding angles that are equal and sides that have some proportional relationship. This proportional relationship usually is in the form of a ratio. And that's going to be where a lot of our focus is going to be spent today. Also, if you're talking about something that's similar, typically they use some kind of a sign like this. Actually, it reminds me of what's on top of this equal sign when we talk about congruent. Some students refer to it as kind of a Nike swoosh, but the idea is that you know that if you have just one of these, it talks about that they are similar. So let's go through and kind of look at this pairing here. And I'm actually going to use the highlighters to help me a little bit. It says determine if these triangles are similar, and if so, what's the ratio? So first of all, as I start looking, A has an angle of 1 band, and so does F. So those two seem to kind of match up. B has a marking of 2, and so does E. Okay, those two seem to kind of match up. Then C and D have a matching of the 3 bands. Now, if we want to see if these are congruent, we kind of have to have the 3 angles that are congruent, and then we have to be able to show that the sides have some kind of proportional relationship. So if we look at this, if we made a list, we can tell that angle A is going to be congruent to angle F. Angle B is congruent to angle E. And angle C is congruent to angle D. So notice that none of these are kind of related in a way that you can look at it and go, oh, well, I could tell by looking at it, because they're not even pointed in the same direction, so they don't even have the same orientation. So now if we want to go and match up sides, let's go from this one to this one, so we keep our pairing alike. So blue to pink in this one is 15. Blue to pink over here is 20. So 15 over 20. They both have 5s in common, so I can reduce that down to 3 over 4. So if these triangles are really similar, that means that all the rest of them should have sides when we match them up that reduce down to 3 over 4. So let's go to the next one. Blue to green is 15, and blue to green here is 16. So 12 over 16. 4 is going to both of those, 3 times here and 4 times here. Well, so far so good. The last one to look at is pink to green, which is 18 here and 24 here. Now 6 would go into both of those, goes into 18 3 times, and in 24 4 times. So on this one, yes, they would be similar, because all of these have 3 angles that are congruent, so 3 pairs of congruent angles. And then we have to see the ratio that the sides are related by. And all the sides are related by a ratio of 3 to 4. So that means that in this one, all sides related to other corresponding sides by a 3 to 4 ratio. Now, in almost all of these, they're going to ask you what your ratio is. So it's going to be important that you can say, my ratio is 3/4 or 1/2, and it always has to be reduced. So that reducing idea is already built into it. They're already going to assume that. Let's take a look at another example. This one, they're going to tell us that these two shapes are already similar. So I'm just going to use my highlighter to kind of help myself here. But L and Q are related, so I'm actually going to mark L and Q in this picture too. Then M and R are related. Then N and S and O and T. Now that means that we should be able to set up some kind of relationship here. So look, if I can look at this, this is 5 and 6, both happen to be on the same sides. So 5 to 6 is kind of one relationship. Those two are ones we know. They want us to find X, but X in this one matches up with a 2. So that means, first of all, 2 is in the same shape as 5, so I'm going to put it on top just like the 5 is. The X is in the same shape with the 6, so I'm going to put that in the bottom. And then we're going to go through exactly what we did in section 7.1. We are going to cross multiply and then solve. So 5x, 6 times 2 is 12. Divide both sides by 5. I can tell this isn't going to come out evenly, but at least I know, because of the bottom number, that it'll come out evenly as a decimal. At least it won't be one of those ones that repeats over and over again. So x is 2.4. Now, on the picture that I have back up here, it doesn't tell me if these are, inches or feet or meters or anything. So the most I can do is say that it's this 2.4. Okay, let's take a look at another one here. In this one, they give us some measurements. Okay, so first of all, I know by looking at this shape that they're already telling me that these are similar. So that means A and X are going to have to be the same. B and Y. And then C and Z. That also means that A is going to have to be 42 degrees. So it means B is going to have to be 78 because they have to be congruent with the one in front of it. Now if I wanted to find C or Z, I could take 180 and subtract my 78 and 42, the other two angles, to find kind of this third one. But so far not on my list to find. It does say, what does the measure of angle B equal? Now, and really you could answer that in two ways. B and Y match up, so I can see how somebody might write this. Or they might actually go for the measurement that they know that it's 78. Either of those would be possibilities. Now on this one, I think sometimes the color does help on this, so just for a second. B, C is blue and pink here. So I'm actually going to go through, do my blue and pink, and then Y and Z is also blue and pink. Now X is yellow, so I'm guessing the other one up here is going to have to be yellow. And Z is blue, so the other one up here is going to be blue. Now what's nice is this triangle. The top is this one. So I just have to look for the yellow and blue of the first triangle to get that it's A and C.